Hey guys, I want to make a quick video here. All right, we're going to work with two qubits, right? This is the first qubit. This is the second qubit. On the first qubit, there's an X gate, which turns the state of the qubit to a 1. Because remember, when you're working with qubits, it always starts out at 0, the 0 state. So when you add the X gate, it flips to the 1 state. Now, in the second qubit, we have a Hadamard gate here. And obviously, that puts the qubit in superposition. Uh, The way you know that is because you see right here it says 50%. That's one way to know that it's in a 50-50 superposition of either 0 or 1. You see that right here, right? And you can see here 100% that is flipped from 0 to the 1 state, 100%, right? So these are little clues that you can look for. Another thing too, okay, let me play this. Hold on a second, let me play this. So we're going to play the gates on the circuit line. And I want you to see something down here on this diagram. Something to look for when you working with quantum computers, when you're doing your quantum computing. All right, so you see how it flipped. Okay, so we played these two gates, right? Now, the way you read this diagram is we're working with two qubits here, right? So that means we're only going to pay attention to the first two numbers in these two number series, right? Don't worry about the last two numbers. Just focus on the first two numbers of this series. So the first qubit, we added an X gate, which I said it flips it from the 0 to the 1 state, right? So what does the first number here say? 1, because this is in the 1 state. And let's look at the first number in this series. It's a 1. So you have a 1 here in this first number, and you have a 1 here in the first number of this series. And that shows that this first qubit is in the 1 state, right? So let's look at the second qubit, right, in the number series here. With the second number, which represents the second qubit with this Hadamard gate, it says 0. And then you look at the second number here in this series, which represents the second qubit, it says 1. Why? Because it's in a superposition of both 0. The second number here is 0, which represents the second qubit. And in the second number of this series here, it says 1. There's a 0 and 1 here in the second numbers of both of these series. Why? Because this second qubit is in a superposition of both 0 and 1 with a 50% probability of it being in the 0 state, 50% probability of it being in the 1 state, right? So that's how you read the diagrams, right? And that's how you read this percentage key over here. And that's how you know where your gates are. It's like backup info that you can look at. Okay, that's it.